Hey guys, so this is your trainer Anirudh Chhillar. So we are back with one more video of OSPF. I hope you are learning in a good way and a good pace. So let's go for the next video.
So on R1 I'll be using 1.1.1, one loop back over there. On R2 also I'll be using loop back 222. Or do one thing. Here I'll be using 10.1.0/24 network. On R2 in the lane of it I'll be using 20.1.0/24 network. In the lane of R3 I'll be using 30.1.0/24 network. In the lane of R4 I'll be using 40.1.0/24 network. In the lane of R5 I'll be using 50.1.0/24 network. And router IDs will be different. Like on R1 I'll be using 1111. I mean today I'll be using different router IDs, right? Like in previous class I was using router ID same as the IP address configured on their loopback interfaces, right? But here I'll be using some different router ID. So on R1, sorry, first of all on S1 by 0 IP address is going to be 12.1.1, and then on its loopback it's going to be 10.1.1. and let's do one thing, let's draw a diagram. Here I'll be using let's say 30's network is also in area 1. Here let's say it is area 1, and here let's say that it is area 2. So this time we are going to implement two different regular areas even without using backbone area. So we will see, or I will show you that okay, by default prefixes cannot move from one area to another area. I mean from one regular area to another regular area if you are not having any backbone area. So it is mandatory for you to implement a backbone area along with regular areas if you want to establish communication, or I mean if you want to establish reachability in between two different regular areas, right? So it will be mandatory. So we are going to prove it now. So this is R1. On R1 I have located an IP addresses, and then after router OSPF 1, router ID is 1.1.1, network 000.245.245.245, and area will be, tell me, 1. Then after we can move on R2 as well. Interface serial 1 by 0 IP addresses are going to be like 12.1.1.2. Then on its S1 by 1 IP address will be 23.1.2. Loop back 20.1.1. Router OSPF 1 router ID will be network area 1. Interface serial 1 by 0, 23.1.3, 34.1.3, and the loopback will be, and this time you cannot use that command 000, is not it? Router ID is going to be 333. Then interface serial 1 by 0 IP OSPF 1 area will be 1. On its loopback will be area 1. On its serial 1 by 1 it will be area 2. So IP OSPF interface brief, is not it? So it must form neighborship see with R2. So it has formed. Then you can move on R4. You can enable OSPF on R4 as well. First of all, allocate an IP addresses interface S1 by 0. IP address will be 34.1.4, and on its S1 by 1 IP address will be 45.1.4, and in its lane I'll be using 40.1.1. Router OSPF1 router ID is 4.4.4. network 000, area will be 2. So now you will see that on all interfaces of this router, area 2 will get enabled. Finally, let's move on R5. S1/0 IP address is going to be now 45.1.5. Oh, sorry. 50.1.1, and here Dr. OSPF1, Dr. ID is 5.5.5 network. Now, if you move on R3, R3 is a center point actually, or R3 is a shared router for area 1 as well as area 2. Means R3 is connecting with area 1 as well as area 2. Now the thing is, it is having neighborship with both of them, as you can see here. Like R3 is having neighborship with R2, and as well as R3 is having neighborship with R4. Now this R3 must maintain its database table. Yeah, it is. It is having database table of area 1 as well as
area 2.
Fine. Have it generated any summary LSA here? Or is this router working as an ABR?
No.
Because if it is working as an ABR, then it must have specified here that okay, it is working as a area border router. Are you getting a point or not? Fine. Then after, you can check its routing table. It must have all routes available. See, 10, 20, 30, 40, 50, all of them, and all of them are coming as intra area. And this router is having all these prefixes inside its own routing table because of it is working in both areas. It is participating in both areas, but prefixes will never move from one area to another
Area.
Like if you move on R1 and if you configure show IP route command, only 30 is prefix is there. Show IP OSPF database, it will be having database of area 1 only. So how many routers are participating in area 1 now? 3. So it is having 3 router LSAs. Are you getting my point or not?
Yes.
So in this way, it has proved that by default prefixes information will never move from one regular area to another regular area without having an ABR. So is there any question related to it now? Fine. How can you solve? I mean, let's say that I want that they must exchange their routes with each other. So what should we do now? How?
As you said in
No ABR and AS.
earlier, but use different processors and redistribute them in R3.
Exactly. I think I have already discussed this methodology with you theoretically, not practically, right? So today, I mean, now I'm gonna to perform that practically. That I said that if you are having 2 different regular areas, they are connected with each other without having backbone area, without an ABR. So by default, prefixes can move from one regular area to another regular area. But the thing is, like, by having backbone area, you can solve this problem. And if you cannot have backbone area, then you can use redistribution. Here I can achieve this task. I can solve this problem by performing redistribution as well on R3 itself. What will we require to do here on R3? Let me remove this process from here. Let me do it. Router OSPF, let's say 1, process 1, right? Then router ID is like here, let's say 3.3.2.1, or let's say 3.3.3.3. Then interface serial 1 by 0, IP OSPF 1, area is what? 1. Then loopback 1 will also be in area 1. It has formed neighborship with R2. Now router OSPF run another process of OSPF on the same router. Let's say it is 2, and router ID is like 30, 30, 30, 30, something like this. And then go to interface as 1 by 1, IP OSPF 2, area is what? 2. So it must form neighborship with R4 as well. And now again all routes will be available in its own routing table as intra area. But now the problem, problem is that prefixes cannot move from one process to another process. And if you want them to put from one process to another process, then you have to perform redistribution. To configure redistribution here, the command will be very simple: router OSPF 1, and then you can say redistribute OSPF 2, and then you can also specify subnets keyword. Then you can move under router OSPF 2, and then you can say redistribute OSPF 1.
Subnets.
Now this router will become exactly ASBR. Is not it that another process is also there, one in it also it is working as an, and you are redistributing external out from OSPF 2, is not it? So this time you have performed redistribution here. So R1 must have all those prefixes here. R5 must also have those prefixes here. From R5, what happened? Light. Have you understood it?
Yes, sir.
That how can we solve this kind of problem? By just using multiple processes on border router, and on that border router use separate process for each area, and then perform redistribution. Redistribution is not possible from one area to another area. Redistribution is possible from one process to another process only. Even if you are using same area, here area 1 and here also area 2, area 1. In both direction you are using common area, but on R3 you are using two different processes. Then also routes will not go from one process to another. Hello. By default there is a rule in OSPF that prefixes cannot move from one process to another process. Does not matter whether you are using common area or not.
Yeah.
Even in place of area 2 you can implement area 1, but then configure multiple processes on R3 itself, and you will find that prefixes will not go from one process to another process automatically, without performing redistribution. So if you want to take prefixes from one process to another process, then it will be mandatory for you to perform redistribution. Tell me, if you do not want to perform redistribution here on R3, do one thing: no router OSPF and no router OSPF 2 as well. So I have removed both areas, both processes from here. Do show IP OSPF neighbor, it does not have any neighbor. Do show IP OSPF database, it does not have anything inside its own database. Now say router OSPF only one, process ID 1. Now router ID is what? 3.3.3. Then interface S1 by 0, IP OSPF 1, area is what? Area is what? 1. Then interface S1 by 1, area is what? And then loopback 1, area is 1. Once again you will see that prefixes will not go from one area to another. However, this time you are using common process for both areas here. Fine. After it, on R3 itself, if you want that, okay, they must, these areas must exchange their routes with each other. make it ABR. And to make it ABR, it must have at least one interface in backbone area. So you do one thing, create one another loop back, let's say loop back 10. Or you do one thing, do not create any extra loop back. Just put its loop back 1 itself in area 0. Like interface loop back 1 IP OSPF 1 area is what? 0. Once you will put this loop back in area 0, now it will become an ABR. Let me show you that it have become now ABR. Show IP OSPF. So once you will configure this command show IP OSPF, it will show you that it is working as area border router. And then after, you will start to see here that show IP OSPF database. Now it will start to maintain the database of area 0. It is having only one router, let's say in area 0. Can you see that?
Yeah.
It is having only one router, let's say in area 0. You know why? Because only one router is participating in area 0. That is R3 only.
Yeah.
And only one link was there in area 0, which was loopback only. That is why it is showing you only one link under its router, let's say of area 0. Then some RLSs are there, then it is also having the database of area 1 as well as area 2, and also it is having some RLSs for those areas. What does it mean? That now if you move on R1 and if you check its routing table, all prefixes will come as inter area. Even if you move on R5 as well, then also you will find all prefixes are coming as inter area. Have you understood my point?
Yes.
That you have two solutions of it, either make it ABR or ASBR, perform rate distribution. But rate distribution can be done after using two different processes. Fine. Now I wanted to make you understand something related to network types as well. In previous class I taught you that how to change your network type on serial interfaces. Even on serial interfaces as well, I configured its network type as broadcast, and on Ethernet link I configured their network type as point to point. Today I will prove you that if you are having more than two routers in a multi-access network, and then after if you configure the network type as point to point, what can happen, right? So let's do one thing. Let's take one switch here. And now what will I do? I will be using their fast Ethernet 0x0 here of R4's Ethernet 0x0 as well as R5's Ethernet 0x0 will also be connected with this switch. So now in this multi-access network, how many routers are there? 3. And this is a common multi-access network, is not it? And now I'm gonna to allocate an IP addresses here. Like what will I do on R4's FA0 by, on all routers FA0 by 0, I'll be allocating IP address in this way. Like, tell me. 192.168.1.1. On R3, 192.168.1.3. On /24. On R4 it will be 1.4. On R5 it will be 1.5. Understood? Fine. Let's move on R3 now. One dot. And IPOSP1 area is what? 2. Then I will move on R4. 1 dot. on R5 also. Dot 5. Understood? Fine. Let them elect their DR and BDR now. On R3, I'm gonna run this command try to OSPF neighbor. You see that R5 have been elected as a DR because R5 was having highest router ID, and all of them started to participate in OSPF within a time period actually. Like if you enables OSPF on other routers before expiration of wait interval, then all of them would participate in the election of DR and BDR. So this time you can see that R5 has been elected as DR, whereas R4 has been elected as a BDR. Now let me do one thing. On R3, I'm gonna to shut down its S1 by 0, its S1 by 1 as well. I've shut down it now. So this time this R3 is having neighborship with R4 and R5 with using Ethernet connection only, and DR BDR election is there. Now what will I do? I will configure the network type as point-to-point on all devices. Like on R3 is FA0 by 0, I'll say IP OSPF network type is what? Point-to-point. In same manner, I will move on R4. I'll configure its network type as on R5 also. Network type is what? Point-to-point.
So what it will happen if we change the priority as 1 and 0?
Okay, you said, I mean, you wanna say that if we configure its parity as 1, even we are using its network type as point-to-point, right? What will happen? In case of point-to-point, there is no election of DR and BDR. Let me show you. Interface FA0 by 0, IP OSPF priority is what? 1. Then go to R4, configure, go to R3 as well. See, and if you say debug IP OSPF adjacency, understand? See, oh God, ignore due to unknown. Neighborship is not there, but it is getting update from there. So you understand what I mean to say, that it is, I mean, in this way problems can occur if you have configured the network type as point-to-point and if you are having more than 2 routers. Now do one thing, have only 2 routers in this multi-access network, and to have only 2 routers, what can we do? We can move on R3 and we can move on R5, and on R5 I can shut down its FA0 by 0. Just shut it down. There will not be any problem. Now R3 can form neighborship with R4 without any problem. See, and it will not go down. Even you can learn. See, tell me, your learning prefixes from 1.4. So I hope that now you have understood that what type of problem, what can happen in your network in case if you are having more than 2 devices in a multi-access network, and if you have configured the network type as point to point. So if you are having an issue, please let me know. Fine. I'm gonna remove it now once again. Fine. So on R3, on its S1 by 0, on S1 by 1 also, on FA0 by 0, shut it down. On R5 also, sorry, on R4 also shut it down. Fine. Again, I'm using the older network now, right? So, but this time area 0 is existing in between area 1 and area 2. Let's do one thing. This time let's change this diagram once again, so that we will require to have, tell me, virtual link. This time, in this case, we are not required to have virtual link, and before going to configure virtual link, let's configure some other things as well. Like, let's say that you want to configure static neighbor in between R1 and R2. By default, their network type is what? Point to point. Let's say you want to configure static neighbor, or you want to send unicast update messages, or unicast messages, unicast packets, unicast OSPF packets towards your neighbor. So if someone have asked you to send only unicast OSPF packets towards your neighbor, then you have to configure your neighbor statically. So now go to OSPF 1, say neighbor is 12.1. What is it saying? So in case if your network type is point to point, then your static neighbor is not allowed. Understood? Even if I configure the network type as broadcast as well, let's say this is S1 by 0, then I'll say IP OSPF network type is what? Broadcast. Then I will move on R2, on its S1 by 0, IP OSPF network type is what? Broadcast. Then they will form neighborship, they will elect their DR and BDR, let them elect their DR and BDR. Just wait, it have came up now, right? Fine. Show IP OSPF neighbor. Who is DR? 2, because 2 is having higher router ID. Fine. Now if you want to configure neighbor statically here, you set neighbor. So remember that in case if your network type is either point to point or broadcast.
Even point to multi-point.
Wait. Whether it is point to point or broadcast, you cannot configure neighbor statically.
Yes.
Even in point to multi-point also, you cannot configure your neighbor statically. Are you getting my point or not?
Yes.
Now, if you are having hub and spoke topology somewhere, then you will always prefer to configure point to multi-point only. Your network type as point to. See, remember that if you are going to implement OSPF in hub and spoke topology, like here also I can design that type of topology. Like, let me demonstrate it on Paint. Let's say this is R1 and this is R2, this is R3, this is R4. Now the thing is, like, you want that R1 must form neighborship with R2 then R1 and R3 must form neighborship, then R1 and R4 must form neighborship, but R2 and R3 must not form neighborship with each other. Then you have to use the network type as point to multipoint. I mean, in this kind of situation, in this kind of network, you can configure your network type as point to multipoint. So if you are going to implement this OSPF over NBMA non-broadcast multi-access over NBMA, and if you talk about the NBMA address, NBMA networks, non-broadcast multi-access networks, your NBMA networks can be either fully meshed networks or hub and spoke or partial mesh, right? So if you are having your NBMA topology as, or NBMA network as hub and spoke network, hub and spoke topology, I mean, if hub and spoke topology is there, then tell me, if hub and spoke topology is there, then you must use your network type as point to multipoint. And if you are having NBMA network as fully meshed network, then you must use either broadcast or non-broadcast. Because you are talking about NBMA network, then you have to use your network type as non-broadcast only, not broadcast. I will teach you all these things during DMVPN. I'll teach you all these things during DMVPN only, dynamic VPN, because here we are not having frame relay. In place of frame relay, now because frame relay is not there, it means we do not have NBMA, but it's not true that we do not have NBMA. Even DMVPN is also known as NBMA, non-broadcast multi-access. So I'll be configuring. I mean, first of all, I have to teach you DMVPN, and then after I can go for this network type. However, I will teach you that how can you configure all these things, right?
Yeah.
So let me show you how. And the actual effect of this command, you will go through this command, or you will go through this configuration during DMVPN only. So whenever I'll go for DMVPN, then I'll teach you that, okay, in this way you can use this network type point to multipoint, right? But here at least I will tell you that how to configure it, right?
Yeah.
But remember that you will be using this point to multipoint network type in that case where you are having your topology as hub and spoke topology.
Okay, so that's the end of today's video. So I hope you learned something new today. We'll be coming with few more videos of OSPF, guys. See you later. Thank you.